All right, looks like we're live. Let's make a little bit of an announcement on the Discord server. Just a second. All right, so this is going to be camera. Not really camera, it's actually a red circle, right? Because we're live on Twitch. So the topic of today's stream is going to be programming language in Python yet again. So astrologers proclaimed the week of Python. So there's nothing I can do about that. We are programming in Python today. Hello Aritra 1911, welcome. So let me find the source code of the language we're developing today. So you can find the source code of this language in here. iGoodDog, what's up? Hello. And I'm gonna put the link to the source code of this language in the description. So this is the source code. There we go. So the language is called Porth. The language is called Porth because it's a fourth, but in Python, right? So yeah, there's a description of this language in here, so if you want you can read it. And let's take a look at the language itself. It's a pretty wacky language, not gonna lie. So it's like fourth. You can basically use some sort of numbers like 35, 34 and 35, and that essentially means that you're pushing those numbers onto the stack. And yeah, this is a stack-based language, just like Porth. And then if you issue command plus, it will basically take the top two numbers on the top of the stack and just sum them up and put them back on the top of the stack. And there's a special command to print what's on the top of the stack. It's called dot, and that simple program essentially sums up these two numbers and prints the result, right? So, and this is pretty much everything our language can do right now, right? But we are working on making it more powerful, right? Specifically today, we're going to work on conditions and loops, right? We're going to introduce condition and loops to that language, and thus making it a little bit closer to being Turing complete, right? So that's what we're going to do today. So if I try to run the language itself, right? So it's a basic Python script, right? You can work with programs in two modes, a simulation mode and compilation mode, right? Essentially, you can just simulate the program that you just wrote without compiling it. So this is going to be like this. There we go. As you can see, it takes 34 and edit 35 and just print it out, right? So, and what it did, it literally interpreted this entire sequence of commands. But what you can do also, you can try to compile this entire thing, and what it will do is generate assembly out of the original source code and compile that assembly and link it into a native executable. And all of that done by that Python script. So here is generated assembly. So this assembly is generated from this source code. Let me show the source code. Where is that? It's going to be full Porth. Right. So this assembly is literally generated from this line, right? And depending on what you put in here, the assembly is going to be different. And then we compile it down to an object file and then linked into a final executable. And if you try to run this executable, right, it will say 69. So I'm going to show you that there's nothing up my sleeve. If you take a look at the file, you will see that it's a ELF64 executable, x86-64, statically linked and not stripped, right? So, and also you can do LDD to confirm that it doesn't depend on anything. It's just like self-contained executable. That's what it is. So, and it's generated from the foo.porth file, right? So you can modify it. Maybe you can add something like 420 plus and sum them up and just print this entire thing. And if you try to simulate this entire program, right, you will see that it prints 69 and 420. And then if I try to compile this entire thing and run the compiled program, it acts, you know, the same. It behaves the same, right? So, yep, that's what we have in here. But unfortunately, our language doesn't have very important constructions such as conditions and loops. And that's what we're going to be doing today. We're going to be implementing conditions and loops. Will this be on YouTube as well? Yes, I do plan to put this entire series on YouTube. Hello everyone, how are you guys doing? So, I think it's gonna be pretty much interesting. So I think I need to create like a playlist for the Porth series. So I suppose I'm gonna put the link to the playlist in the description. I think I haven't created that list yet. So I'm gonna do Porth series, and I'm gonna put TBD. So when this entire thing is gonna be on YouTube, I'm gonna actually put this entire thing in the description once I make the playlist. All right, so let me see. So here is the compiler itself. So to introduce if conditions, I think we need to be able to actually work with booleans, right? I think we need to be able to write conditions. Right now we are incapable of doing that because the only two operations that we have is plus and minus, right? We want to have at least something like, I don't know, equal, right? So at first we want to be able to check if something is equal to something else, and then based on that maybe branch to a different part of execution, right? So I'm going to introduce yet another operation in here, right? And I have a lot of conditions and actually assertions that depend on the amount of ops, right? So essentially, yeah, so I expect 4 operations in different places in here, and as soon as I introduce a new operation, all of these places will break, and they will tell me where I need to make the changes to add support for this entire operation. Even though Python is dynamically linked language, I still can do something similar to compiler-assisted refactoring in it by putting a lot of assertions. For MSAL4, I hope I'm pronouncing them correctly. Thank you so much for tier 1 subscription, your first subscription, by the way. Thank you, and welcome to our Epic Python Club. How about that? How are you guys doing? Thank you. Thanks for uploading the videos to YouTube. They are pretty fun to watch. Thank you for supporting me. It's actually pretty fun to produce as well. So yeah. I hope I actually explain everything clear enough. So yeah, because the most important thing for me is to actually be understood, right? So because I'm trying to explain my ideas as clear as possible, and I want people to understand them, if that makes any sense. Cheers. Alright. Oh my god. So for MSAL4 is gifting 5 tier 1 subs to the Tsoying community, and everyone who got the sub, welcome to the Tsoying community, I suppose. Thank you so much. So I was gonna play for a while. I'm gonna just try to run my script and just see in what places it fails and just fix those places. Alright, so this is gonna be Porth. So don't worry about that. Like, you're literally giving me money. Like, I cannot be mad at that. Seriously. Thank you so much. Gypsy Bard. It's actually, yeah, it is a Gypsy Bard. It's like a small portion of it. Gypsy song, I think. Yeah, from Friendship is Witchcraft, I think. I don't know. I don't know how many people remember this series, but yeah. This was so long time ago. Like, I mean, it's like almost 10 years ago, all of that stuff. Feels so old. Holy shit. Alright, so let's try to simulate this program, and I suppose the way we're gonna use that is essentially, right, I do 34 plus 35, and then I push 69, and then I want to put equals in here, right, and that entire thing should produce true or false. Well, in this case it will produce true. Right. Another day, another Porth stream, yeah. You know what we say in Black Mesa, another day, another dollar. Right. Hello Manasoma, hello. Loop 327, Saberdine Yale, hello. How are you guys doing? So yeah, what I'm trying to introduce in here, I'm trying to introduce the equal operations. So let's actually go ahead and do that. I'm gonna do a simulation of our nation, and as you can see, it instantly failed, and it failed in a place where I put an assertion. Okay, so we introduced a new operation and we need to handle that operation properly. Right, so if the word is equal to equals, we have to return equal operation in here. Another day, another unforeseen consequence. Yes. Alright, so here's another thing. This entire idea of putting as many asserts as possible into dynamic language actually makes programming in a dynamic language more or less bearable for me. Yeah, so it's not ideal. Like, ideally, I would like to program in a statically typed language, but making as many checks as possible also kind of works. So, I don't know. So I can do a process that sort of resembles compiler-assisted refactoring, but not really. So let's create a constructor for the equals operation. So this is going to be equal, and I'm going to return OP equal, like so. So here is another place where we have this condition, and this is in a simulation, because I was trying to simulate this entire thing. Okay, so if this entire stuff, if the operation is equal to equal, right, I need to pop two values from the stack, compare if they're equal, and push them back onto the stack. So in a simulation mode, this value is going to have type true. But I think when we compile this entire stuff, we're gonna lose all of the information about this entire thing being Boolean. I'm gonna show you what I mean. So I'm gonna update the assertion, and I'm gonna just do this entire thing. There we go. So as you can see, it prints true. But if we try to write a compiler that supports this operation, I think we won't be able to print true in here, because again, we're losing information about the type. So one of the things we may want to do is probably convert it into an integer, right? But let's not maybe jump ahead of ourselves. Let's just leave it as it is, implement the compilation, and see the discrepancy between the compiled and simulate versions. Okay, so we added support for this entire thing. And now if I try to compile this entire stuff, yet again it will fail in all of these assertions. There we go. If OP equal, right, and we'll have to do something like this: 1, 2, 3, 4 equal, like so. Do I need to? I don't know. I'll definitely need to pop rex, right? I'll need to pop rex. I need to pop rbx, and just do something with them, right? I'll need to do something with them. But the question is, what should I do with them? I remember that some time ago I discovered a pretty cool instruction. It's called conditional move. In x86-64 there's a conditional move. Do you guys know about this one? So I think we can use that one. So I think it's literally called like C move or something. Yeah, conditional C move. Yeah, there we go. Yeah, and I think we're gonna use this one. You know how I discovered this operation? I was trying to see if the naive implementation of max or min in C introduces branching, right? So if you go to C, right, and you implement something like max, and essentially if A is less than B, then means you want to return B, otherwise you want to return A, right? You always want to return the biggest number. And the funny thing about this stuff is that this the compiler usually does not introduce any branching into this implementation, which is actually kind of cool. So if you take a look at Godbolt, so let me actually put this entire thing like so compilation failed because what's that? Expected because it's a question mark, of course. There we go. So as you can see, it actually never introduced any branching. So instead, what it uses instead of like jumping around and stuff like that, it just uses conditional move. And this is how I discovered it. I just like was curious, does that introduce any branching? How the compiler would implement something like this? And it implements it in like literally 3 instructions, which is kind of cool, right? So it's kind of useful to sometimes look at what compiler generates, because you know, discover something interesting about architecture that you're working with. So, and maybe we're gonna use something like this, right? So if I remember correctly, right, it looks at the flags in here, right? It looks at the flags and it performs something depending on the flags. So let me see. So I'm gonna go to Porth Pi. We're gonna probably use CMP, right? So x86 CMP. So essentially it's gonna be out, right? CMP RAX RBX, not TBX, RBX. Compared to operands, right? So compares the first source Hamikovi. Thank you so much for 19 months.
Sodin Comrade 7.
Sodin Comrade. Thank you so much for 19 months of tier 1 subscription. Thank you, and welcome to our epic assembly club. How about that? Cheers. So let me actually go back to the code bolt, right? So what do they use to actually do conditional move? They do in fact use CMP. Would you look at that? They do in fact use CMP. So they compare these two things, then they're moving that one or conditionally move that one. This is actually the most straightforward code I've ever seen in my entire life. Like, holy shit. This is actually pretty cool. Whether this entire thing is equal or not, I have an idea. What if we're gonna put the result of the comparison into something like our CX, right? And by default, it's going to be equal to 0, right? So that means it's false. So in our case, 0 is going to be false, 1 is going to be true, right? And then we pop out these two things, we compare them, and we essentially move 1 into RCX, but conditionally, and only when these two things are equal. So is it something like C move AQ? There's no AQ, there's E. Move if equal. Okay, so that's perfect. Okay, so C move. All right. So I think for now this is a good solution. Maybe not ideal, but good enough. Does not introduce any condition or anything like that. Right? You just like move 0. By default, it's going to be 0. Then we take these two things and we compare them with each other. And if they're equal, we're going to put 1 in here. So yep, this is how we're going to do all of that stuff. All right. So did I update this entire thing? I think I need to increment this entire stuff, right? And I think I literally forgot new lines in some of the places. Yeah, there we go. Okay, invalid condition of opcodes and operands. Okay, let's take a look at what's going on here. Okay, opcodes and operands. Very interesting. So you can't do that. Is that because of the weird mode we're in? Maybe we have to explicitly say that we want a 64-bit or something. That's very strange. Like, I don't understand why it wouldn't allow us to do that. So I'm gonna just in case put bits 64 in here. I'm not sure if it's gonna, like, you know, fix anything, but yeah, it didn't fix anything. Invalid combination. So I don't know. Like, I can always. So in Godbolt they only use operands, right? So I can always put something like RDX, right? It's gonna be 1, and just put it in here, and it worked. Okay, so apparently you don't have an immediate value in CMove. which is kind of strange because I think so there's R. I suppose R is a register, and what is M? I would it's a memory. Ah, I see. You can only put a register or memory in here, if I understand correctly. Okay, that makes sense, I guess. So memory or register. All right. So I don't know. x86-64 is actually so overbloated. You would expect each like instruction have all possible different combinations of like being able to take the register, memory, immediate value, and so on and so forth. And it's kind of surprising when you discover, you know, in x86-64 something that, you know, is limited like that. Anyways, so let's try to compile. We already managed to compile this entire thing, and if I try to run this entire stuff, it prints 1. And this is the main discrepancy between the simulated and compiled version, as you can see, right? So if I try to simulate it, it will print true because of how type system of Python works, right? Because it pushed Boolean in here. But if I try to compile it and run it, it will print 1, which is not necessarily what we want, right? So I think to keep the discrepancy between the simulated and compiled version to minimum, when we are doing comparison in a simulation, we're going to be casting it to integer, right? Something like this. So now here's the compilation, and here is the simulation. So in both compilation and simulation, it just prints 1 in here. So that's Pogue, not gonna lie. Right, well, we can also check some other things, like let's try to compare it to 420. In a simulation, it should print 0, okay? In the compilation, something like this is going to print 1. It would be kind of cool for the compilation mode to accept something like -R and also automatically run the entire thing. I think that would be actually pretty cool. So maybe this is precisely what I'm going to do right now. In any case, I need to compile, I need to commit the new operation that we just introduced. And then we're going to introduce a flag. Introduce equal operation. There we go. I'm going to push that right into the repo. And if you want to take a look at the source code of this entire thing, you can find it in the description. And for people in the chat, you can find it in here if you're interested. Okay. All right, that's pretty cool. Let me see. We don't really have enough machinery in here to actually parse the additional flag. So, but that would be kind of cool. So maybe I'm gonna put some sort of a to do in here. -R flag for com that runs the application upon successful compilation. There we go. I'm gonna just put to do in here and continue working on what I want it to work. So since we already can compare things, I think the time has come to introduce some conditions. So I accidentally removed my example. I don't know why. I think I'm an idiot. All right, so full Porth, right? So let's introduce the following thing: 34, 35 plus equals 69 equals. And how can we introduce conditions into like a stack-based language that uses reversed Polish notation like this? So syntactically, I think it should look something like this. You put if in here, right? And what if will do, it essentially will check that you have 0 or 1 on the top of the stack, and then you can have then body and then else body, like so. Not op. I need to actually do something like this. There we go. So, and essentially, depending on whether it's true or false, it's gonna continue executing and then jumping to the end or jumping to the else. Right, so I think syntactically it should look like this, right? So, and if this is true, we can print something like, I don't know, 69, and if it's false, we can print something like 420, but maybe twice. I don't know. So something like this, right? So for now, we cannot print any strings yet. But in the future we'll be able to maybe do something like hello, right, and just like write the entire string, right? I want to be able to like push a string literal onto the stack, right, and by doing that it will automatically put it into the data segment, right, and then this entire thing will push a pointer to the beginning of the string in the data segment, right, and we'll be able to just write it to the standard output at some point. But we don't have these abilities right now, but in the future we do plan to have that. So syntactically I want this to look like this, right? Syntactically I want this to look like this. So this requires introducing like 3 different tokens. I think for now I'm going to introduce only 2 of them, right? So let's only implement if without else, and once we nail down if without else, we may try to introduce else, right? So that's going to be the idea essentially. That may require like changing fundamentally how we interpret and compile the application, because now you can jump around in the execution. Before if, the execution was always linear. You would always execute from the left to right or top to bottom, whatever. But in here you're starting to jump around. So that means we'll have to iterate instructions by maintaining instruction pointer, right, and just modifying the instruction pointer. If is a Porth instruction, not a function. Yeah, it is. I would even say that it's more of a compiler instruction, right? So because it's not going to have a really runtime equivalent, it's more of a compiler construction that instructs how to, jump around execution. Okay. So let's go ahead and just introduce this entire stuff. So maybe I'm going to do 420. To Porth pi. So it's going to be OP if, right? iota. All right. So I need to start with the simulation. Okay. So it fails in here in the parsing. All right. If word equal if, I need to return if, I suppose. I think that makes sense. Return op if, like so. And I forgot to update the assertion. Okay. Oh yeah, okay, so that's very interesting. Yeah, I actually introduced a couple of tokens in here, and I didn't create the operation for the AND as well. Right, okay, let's introduce the AND. And here, we're going to do the following thing. If and return AND. So 6. It's gonna be 7. And return OP and. Okay, so this one is rather interesting. If. So this is a simulation already, right? This is a simulation. If operation is equal to if, we have to extract the supposed condition from the top of the stack, right? And if it is equal to 0, we have to skip the entire, the entire body and jump to the end somehow. Jump to end, but we don't really know where end is located, right? So we literally don't know where it is. So I think we need to do some sort of like a pre-computation step. Essentially, I think what we need to do after we parsed all of the tokens in here, we need to iterate through the entire program once and sort of cross-reference if and ends. So essentially, if you encounter if, you remember where you encountered it, and if you found a match in end, you add the location of end to if. So then if fails, it knows where to jump. You know what I'm talking about, right? It knows where to jump. I think it's rather good idea, actually. And it doesn't really need any cross-reference. It's only important for if right now to know how to jump to the end. So yeah, while parsing everything, maybe we can do that while parsing everything. Wait a second. So we're parsing the token here, right? And maybe as we parse, we can do all of that. But I'm not sure how. Like, we have a very how to say that, special way of parsing this entire thing. So it would be easier to have a separate function that takes the output of the parser and does all of the cross-reference. But I'm thinking, can I merge this function with the lexing process? Is that a thing I can do? That would be kind of cool, but I'm not sure. So because lexing is just a generator, and yeah. Though, if I get rid of the list comprehension in here and rewrite it into like yield thingy, like in lexline, I think it would be easier for me to actually maintain some sort of a state in here that will help me to do the cross-referencing. That's actually a pretty pogue idea, I think. So, all right, that's something that we can do. I want to play with that idea, actually. So I'm gonna go in here and let's go to the Python, IPython. And then I want to load the file Porth, Py. I hope my sound is okay. The last time I tried to use Porth on the stream, it actually started to like hog my entire CPU for whatever reason. So yeah, okay. So I can try to lex a file. So this function is actually pretty cool because I can just feed it a file, full Porth, right? And it literally returns like a list of these things, which is rather strange because I would expect this thing to be like a generator. Because if you try to lex a line, 1, 2, 3, 4, it does in fact return a generator. So this entire thing, for some reason, does not act like a generator. So sound is fine. Okay, thank you so much. I really appreciate that. So if we try to rewrite this entire thing as a generator without like list comprehension, so what we're doing in here, we want to iterate the lines of the file. Okay, is the lines a generator? Right, if I open a file, right, look, I open a file, full Porth, right, Porth, for reading, I'm reading the file, and then I read the lines, and I take a look at the type of this entire thing. Is that a generator? No, it's a list. Okay, so first it builds everything and then, okay, that makes sense, it is in fact a generator. Okay, anyway, so let's actually just go ahead and rewrite this into a generator, like so, and then I'm gonna iterate this entire thing, and then essentially I'm going to just yield, like so, and I just wonder what's gonna happen to this entire thing. So load, okay, and let's reload this entire thing, and lex file, full Porth, there we go, and it in fact returns a generator. So if I can return a list out of it, and it works like a list. Okay, that's cool. That's pretty cool. Oh shit. So yeah, even you cannot rewrite it as a generator, because as you encounter if, you'll have to wait until you find the end so you can update the token. I didn't think it's gonna work that well. I don't think it's gonna work that well. We'll have to introduce a separate function, right, that does the cross-referencing for us. So let's actually do something like cross-reference program, and it will take a program and just return a new one. Right, I think this extra step, like explicitly having a function for this extra step, is important, because there's like really nothing I can do about that. So, and maybe because of that I want to just get rid of this entire stuff. Yeah, okay. It is what it is, and it isn't what it isn't. Is it not? I think it is. Okay. Okay. So we're going to maintain some sort of a stack, right? We're maintaining some sort of a stack, and we're iterating each individual operation in a program. What's interesting is that we only care about two operations right now. It's a if and end, and we're gonna ignore everything else. If, to be fair, I think we wanna actually iterate it by IP like that. So this is going to be a range for length of the program, because at some point we'll have to just go back, you know, something like previous, and just set something there, right? So I think it's going to be important. So it's going to be a range. So OP is going to be basically program IP, right? Program IP, and then here we're going to just take a look at this stuff. OP if assert false, not implemented, and L if OP1 actually 0, OP end assert false, not implemented. Otherwise, I think otherwise we shouldn't do anything, because we just need to ignore the rest of the instructions, right? But we also need to make sure that we handle everything. So I need to do count ops, and the amount of operations that we expect in here is 7, right? So exhaustive handling of OPs in cross reference program. Keep in mind that not all of the OPs need to be handled in here. Only those that form blocks, right? So this is specifically for the blocks in here. Maybe because of that I'm going to call this function something like cross-reference blocks, right? Cross-reference blocks. So okay, if I encounter if, right, I'm going to push the current address onto the stack, right? So that's what I'm doing. I'm pushing the current address onto the stack. If I encounter end, I'm going to pop that entire thing. So this is going to be if address stack pop, and now I know where I have to go back in the program and cross-reference the current IP in here. So I already called it IP, so maybe it would make sense something like IP in here. Yeah, there we go. So if right now is a tuple with one element, I think it should become a tuple of 2 elements, right? So when it's cross-referenced, it should become a tuple of 2 elements, with the second element being the address of the end, if you know what I'm talking about, right? So it's going to be the address of the end. All right, so that means I need to take the program. I suppose one thing I want to do, I want to just check, I want to make sure that this is OP if, and can only close if blocks for now, right? And then if IP is going to be equal OP if, and the address of the end, like so. All right, I think that's it. I think this cross-references the blocks properly, hopefully, and I think we're ready to do something with that. All right, so let me try to load the entire stuff. Right, so I'm going to load this entire thing, hopefully, and let's lex the file. Right, so this is going to be full, and maybe I can just load the load program from file. Okay, this is perfect. Load program from file. Foo Porth. Right, so here is the program. Yeah, here it is. It's kind of difficult to see where we have ifs and whatnot, but I suppose if it's somewhere here. So if I try to cross-reference, right, cross-reference blocks, do I return program in cross-reference blocks? Cross-reference blocks. Yes, I do return it. Okay, that's perfect. And list doesn't have a push. This is because it has append. All right, and let me just, I don't know, reload everything. There we go. And oh my god, this is annoying. Cross load program from file. Let's try to load it one more time. Foo Porth. Cross reference blocks. Okay, so if I just load it, okay, so here was the if, and here in if we cross-reference to the end. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and I suppose 8 was at the end in here. Okay, so I think everything got cross-referenced properly. So we can try to use this information to simulate everything. All right, so if I try to go here, simulate program. So here is if. And what I want to do as well is check len OP has to be equal, greater or equal than 2. Okay. So if instruction does not have a reference to the end of its block, please call cross-reference blocks on the program before trying to simulate it. Right. So we can easily catch this situation. So why not instruct the programmer or the user, rather programmer of the compiler, whoever is going to continue working in this compiler, how to actually simulate things. I think it's kind of cool. All right. So and now we just need to jump there somehow. So, but we cannot jump here because we iterate operations linearly from left to right. I think we need to change this entire stuff. Right, we need to iterate the actual indices of the operations, right? And then OP here is going to be program IP. There we go. So, and now I can easily do IP equal OP1. Otherwise, I think we're going to continue execution. All right, that should be it, actually. Should be it. So if we encounter end, I think it will still tell us, maybe not, whatever. I think we shouldn't do anything right now. So it's going to be pass. So once we introduce the else, I'm not even sure. I think end really never needs to actually do anything, right? So end is more of like a marker for the cross-reference block function to know when to set the return addresses and whatnot. Yeah, I think it's fine. All right, so let's try to do that, and this entire thing has to be 7, right? And there we go. Okay, so let's take a look at the original program. Original program was this. So if this entire thing is equal to 69, it should print for 20. Right, if I change it to 70, right, it shouldn't print anything, and it actually crashed. All right. Oh, that's pretty cool. So look at that. Like, yeah. I'm really glad that I decided to assert that specifically. Now I know exactly what I need to do. So I forgot to cross-reference this entire stuff. Okay, so maybe I can cross-reference this thing after I loaded program from a file. Yeah, I think it's a good idea. Cross-reference program like so. There we go. And if I try to run this entire stuff, well, it's not cross-reference program, it's cross-reference blocks. Yeah, cross-reference blocks. And there we go. Okay, so it's still printed for 20. So nothing changed literally. So that's pretty cool. Thank you so much. Yeah, so it doesn't matter if it's true or false, it will still always print for 20. So it didn't really... Oh, I know what's going on here. Okay, so this is complicated. This is because... Yeah, we should advance IP manually. Yeah, this one is very interesting. So yeah, IP still advances further. It still advances further regardless of whether you set it to something, like it just doesn't care if you set it to anything. What we'll have to do is to change this to a while loop, right? While this entire thing is, you know, less than the length of the entire program, we're going to be doing that, but on each operation, we'll have to increment IP manually, right? So, yeah. And here's an interesting thing. If this entire condition is false, we jump to the end of the block. Otherwise, we go inside of the block, right, incrementing by 1. And one of the things we can put into the end of the block is just +1, right? And yeah, I suppose that's what we can do. Okay. And what do we have in here? Simulate program. So IP reference something before assignment. Okay, that's cool. Simulate program. So I probably want to do something like this. IP equals 0. There we go. So now if I change to 70, right? If I change to 70, it doesn't print anything. Okay. So if it's equal to true, it prints for 20. If it's not equal, it prints nothing. So we implemented if conditions on the level of the simulation, right? So we can at least simulate the conditions now. So I think it's pretty cool. We've got conditions. So yesu kawaii freaking desu. Alrighty, but we can't compile them yet. So let's try to compile this entire thing and see how it's gonna fail, right? So if I try to do something like this, as you can see, we don't handle any of this shite. First of all, I think we need to do a similar thing where we gonna start the execution at here. But it doesn't really matter, actually, if you think about it. During the compilation, we don't really need to jump around that much. We only need to translate. So I don't think we need to jump around, chat. I don't think we do. Okay, so this is gonna OP, and if I encounter something like elif op0 equal op if, right? I'm gonna write it like so. 1, 2, 3, 4. So this is gonna be if, and this is gonna be the new line. There we go. And so this one is rather interesting, right? So what I need to do, I need to pop the current value from the top of the stack. Okay, so this is going to be pop rex. And now I need to check if it's equal to 0, then I want to jump somewhere. If it's not equal to 0, I want to continue execution. So the question is, how can I do that? Let's actually Google that. x86-64. Check if equal to 0. How to check if the register is 0 in x86-64? So can I use test? You can do test, okay. Sets the f to 0, and why would you use JE? Isn't JE needed for equal? I think that's kind of sus. I think you have to do JZ. If you just used an instruction that modifies the f before, simply check that flag. Well, test is basically AND, but it doesn't modify the register. So I think in our case I can just do... but why do you... this is so weird. Like, why do you have to have a different here? All these examples are so weird. Yeah, test rex and jz 0. Okay, so this is what we're gonna do. Okay, so out right, and I'm gonna try to do test rex and then out right jz. And here is the interesting thing: where should we jump? Where should we jump? I think the end instruction, right? The end instruction, op end, should generate a label to which we can jump. That's kind of interesting. So end operation doesn't generate any instructions, but it generates a label, right? So, and what's going to be the label? Let's call it something like address, and then we're going to just use the jump address that is available within the operation itself here, right? So, and on top of that, I think I want to do something like assert length op equal to, and let me actually take the error message from here, right? So this is going to be the error message. So if instruction does not have a reference to the end of its block, please call professor and program before trying to compile it. Simulate it. Okay, compile it. All right, so this is going to be address and stuff like that. So in case of the end, I'm going to do out right, and it's going to be address, and we need to actually print the current address in here, but we don't know the current address in here. So that means we still need to sort of refactor this entire loop and just do something like IP equal to range of length of the program, right? Like so, and OP is going to be just program IP. There we go. Okay, again. So, and well, we still don't handle all of these things. All right. So this is going to be something like 7, and it compiles. Okay, let's take a look at the assembly that it generated. Okay, so what do we have in here? So yeah, is that even a correct assembly? Why the fuck did it compile? This doesn't look like a correct assembly, and I'm really surprised that this shit compiled. Address, yeah, there we go. So it's supposed to be like a new line in here, first of all. Second of all, this is supposed to be this thing. And let's try to compile one more time, and full awesome. There we go. This looks like a proper shit. Okay, look at that. So we have if, we pop this thing, we check if it's 0 or not, and we're jumping to this address straight up into the exit. This is the exit syscall. If it's gonna be 1, we're gonna actually push for 20, and we're gonna actually dump it. Right, so we're gonna call to the dump function, which will dump everything. So I think we managed to compile an if condition, right? I think we managed to compile the if condition. So let me try to run the entire thing, and it prints for 20. Would you look at that? It prints for 20. This is actually cool. So if I change, yeah, so it's supposed to be like that. If I put it 69, right, and try to recompile it one more time and run this entire thing, it still prints for 20. Okay, so did I actually recompile it properly? I'm not sure. All right, so this is supposed to be all right, so something is not working. Something is not working. JE and JZ have the same opcode, at least based on the instruction set reference. Okay, cool. That's nice to know. Thank you so much. So I wonder where we did a fucky wacky, and especially oopsie doopsie. I really wonder. So maybe I just, you know, change the order or something. Let me take a look at the code in here. So I pop rex and I just test this entire thing, right? And if it's equal to 0, right? If it's equal to 0, I want to jump to the end, but it didn't jump to the end for whatever reason. So, and the funniest thing is that I think it doesn't really care, right? If I do compile full Porth, right, and just run it like so, it always prints for 20, no matter if it's true or not. Yeah, it's always printed. I don't know. So let's take a look at the full assembly and review this entire thing. so Z was modified so to check if Rex is 0, a single jump is enough. I literally don't see any problem in here. I literally don't. So maybe the time has come to bust out the debugger? What do you guys think? Is that the time to bust out the debugger? We can try to do that and just like step debug and see what the fuck is going on and why it doesn't want to do that. So specifically here I would expect it to not print anything, right? But it still prints. Simulation works fine, but the compilation doesn't. It's actually kind of cool to have this simulation and compilation mode. You can just always compare them, right? And in the future it's going to be useful for metaprogramming, by the way, right? Since you can dynamically like interpret this entire thing, maybe you could use that to generate the code during the compilation and whatnot. Alright, so I think we need to bust out the debugger. I wonder if I need to generate any, you know, debug information. I think I don't have to, though I'll have to look at the AT&T assembly all the time. But maybe that's fine. Maybe that's totally fine. Let's actually do this thing, and I need to break at start, and it actually set the breakpoint properly, and let's try to run this entire thing. So I'm gonna do layout assembly. I think that's how we do that. And also maybe I'm gonna do layout registers, right? So we have a registers in here. Though I can't see any flags or anything like that. I think you want to look at assembly in this case. Well, that's precisely what I'm doing. Thank you. Alright, so here we have that. Okay. Pop Rex, and here it is, and we add them together and we push them back. Then we push this thing, move 0, move 1. Then I pop Rex, pop BX, compare those things, and then move this stuff in here. So this became 0, right? Oh, I see the error. Okay, so I found it. I found it. Sermon, what's up? Sermon, hello. I found an error. This is the bug in equal. I pop 2 operands from the stack, I compare them, but I never push back the result of the comparison in the compilation. Never. That's the bug. That's why it never actually worked, because it never actually popped the right value. So I forgot the push instruction in here. So, yep, that's pretty cool. So yeah, debugging was actually useful because I managed to like force myself to step through the generated assembly, and yep, we found a bug. So I need to push this thing back. To back. There we go. Alright, so let's try to run this entire thing, and as you can see, it doesn't print for 20 anymore, right? If I change the program for Porth to 69, it should now print everything. So now we don't have any discrepancy between simulated version and the compiled version. Okay, we fixed the bug in the compilation. So that's pretty cool. I forgot the new line for the push. Why did it work though? Why did it work? Oh yeah, this is why it worked. So it's totally fine. I wonder if it's like there is like a right line or something, because let me take a look. IPython IPython open something like full Porth for writing. Maybe not. I'm gonna actually do something like out. Right, and the thing I want to do, I want to check what do we have in here. We have right lines, but we don't have right length. So what about right lines? What does it do? Method of thank you Python, very cool. Okay, so that means we'll have to suffer. All right. So this is gonna be push new line. Okay, so let's do the recompilation, and I think we're ready to finally do a committee. So we successfully implemented if, though without any else, right? Without any else. And if without else is kind of useless. Well, I mean, you can do some things, but it's not as powerful as if you had else. All right. So let's remove this shit. Implement else less if, right? And I'm going to push that right into the repo. Finally, we have else less if in our language. That's pretty powerful, not gonna lie. So we're now able to do this kind of shit. And I really like the, you know, reverse Polish notation for this language, because it basically means I don't have to generate AST. That's what's cool about it. Like, I just don't need AST. Notice how I don't build any trees or anything like that. I just like iterate from left to right, and I just generate the assembly. It's pretty cool. So that's pretty cool. Anyways, so let's try to introduce else. What do you guys think? Let's try to introduce else. So it'll be Porth. Porth pie. Pork pie. Interesting. So we're gonna have and this one is gonna be else. And let's just go ahead and do that. Simulate. Okay, so here we fail during that stuff. If we encounter else, I return else, but else is already taken, so I have to do else. Yeah. Def end, and let's introduce def else. Classic compiler development, by the way. Classic compiler development. So else is going to be a little bit more difficult because you will need more, you know, cross-referencing job. But maybe, I don't know, we'll see. I haven't updated that thing, so this is going to be 8. Okay, so... Alright, so cross-reference blocks. Keep in mind that not all of the ops needs to be handled here, only those that form blocks, and this is precisely the case. Okay, so here's if and elif op equal op else. So we encounter if and we push the you know, back address to if onto the stack. So if we encounter else, what we want to do? We want to set the else address to the if, because if fails, we want to jump to else instead. So basically else kind of becomes the new end, if you know what I'm talking about. It becomes the new end. So let's go ahead and do that. So this one is going to be if ip stack pop, right? So we also want to assert something, right? We're going to go back to the if address, and we want to make sure that this is if, right? So because you want to use else only with if blocks. Else, let's put it this way, and this one has to be something like and. Else can only close if blocks. Can only be used in if blocks. There we go. So that's what we want to assert. It's quite important. Alright, so then I'm going to set if ip equal op if the current address. And what's interesting is that else kind of opens a new block that we also need to keep track of. So I'm going to do stack push, and I'm going to push back IP, and that's the address that is going to be used by AND. Right, so this is rather interesting. So you have if, then a bunch of operations, then else, then a bunch of operations, and then AND. Right, you encounter if, you push the address of the if onto the stack, then you go there, you encounter else, then you, by the if IP, you go back to if and set a jump point to else, and then you reset it to else, then you go to end, you reset the else jump to here, and so on and so forth. Yeah, so that's how it's gonna work, I think. Yeah, that makes sense. All right, so if we encounter end, we're gonna have if or else IP. So we pop the address in here, but we don't know yet if it's else or if. So we need to check for both, I suppose. We need to check for both. So assert program if IP. Oh, by the way, I also want to use end for while blocks in the future. Right, we're going to also use it for while blocks. So it's going to be something like while, and then maybe for loops. And is going to be used with so many different blocks. It's kind of interesting. So maybe what we'll have to do in here is like some sort of a condition. If program, so I don't know, block IP. So this is going to be just block IP. If it's equal to op if or op else, we're gonna do one thing essentially, right? We're gonna just you know, set it back, but we're gonna set it back like so. So this is block IP, block IP. Then in the future we're going to have something like op while, and we're going to do a slightly different thing in here, but for now we're going to just say that you know, if can only be used with something. Right. So that's essentially what we're going to have in here. Would you need to compile different executables for Windows, Linux? And if so, what is the difference between them? Yeah, the answer is yes, we'll need to compile them differently depending on operating system. And as Columbiatka in the chat noticed, the interaction is going to be different. On Linux, you can straight up work with syscalls, and it's more or less fine. As far as I know, using Windows syscalls is not really, you know, robust enough, because Microsoft tends to quite often change their syscalls without any notice. So you probably will have to link with WinAPI library or something like that. So you'll have to call the WinAPI functions. The Linux syscalls also change from version to version of the kernel, but at least it's actually properly documented. And you can actually know what kind of changes were between the versions, and you can handle them yourself, right? In case of the Windows, like, nobody guarantees you anything if you're using their syscalls. So yeah. But if we're gonna write a program that doesn't really interact with the operating system, maybe it's not gonna be that difficult to do in the future. We'll see. Maybe we'll have a mode which allows you to, you know, work without any operating system. In that case, it's just like interaction with the operating system doesn't matter anymore, right? So I kind of want to write something simple in this language that works, you know, without operating system, like a bootloader of some sort, or maybe simple operating system. That would be kind of interesting, I think. Yeah. So that's a good question, actually. That's a good question. Thank you. Anyway. So here we're going to do assert false. Assert false. So and can only be used. Can only close if else blocks for now. I guess. It can only close if else blocks. I think that's it. So when I can finally increment 8. Hopefully. Alright, so what do we have in here? So we're starting to work with the simulation of our nation. Okay, go. So So here's an interesting thing. If you encounter else, at all, I think what you want to do is to actually jump to the end, right? You want to jump to the end. So in case of the else, we don't really need to do anything with the stack. We do need to assert that we do have enough operands in there. Else instruction, so it's basically the same thing, right? Else instruction does not have a reference to the end of its block. Please call cross-reference on the program before trying to simulate it. Okay, that's perfect. And then I will be able to do IP equal to OP1, right? So that's cool. So this is kind of interesting because if right now in the cross-reference function, if you encounter else, we go back to if and set its address to else. And if you encounter else, it jumps back to the end. Which means that if you have a false in if, it will jump to else, which will jump to end. I think what we need to do +1 so it skips the else instruction and it starts to actually execute else body. Right. You see? So I wonder if I can draw that, because it's a kind of an interesting situation. So here's my trusty tablet. Thrusty tablet gotcha hyper. Okay. So you have if, then you have some instructions in here, right? You have else, and you have some instructions in here, and you have end. So what end does, it just always jumps to the next instruction. So if it can, right now, it can either jump to the next instruction, basically fall through, or jump to the else. And else right now always jumps to the end, right? So that means if you have false in here, right? If you have false in here, it will jump to else, but else right now jumps to the end, which will basically skip everything. So what I think we need to do when we set up cross-referencing, we, in case of the false, we should jump not to the else, but to the next instruction after else. Right. So in that case, if this is true, we're gonna fall through, reach the else and jump to the end. If it's false, we're gonna skip the else, do the else branch, and then fall through the end. So this is quite important, right? So we need to jump specifically to the next after else, because else indicates that you need to skip to the end. Does it make sense? Yeah, it's a little bit complicated, but we need to keep that in mind. Right, I think it does make sense. Because this is basically visualization of this cross-reference process, right? I really hope that makes sense. Alright. Wait until we get into the while loops. While loops are going to be interesting. Though I think while loops are going to be more like simple, right? Because you don't have two separate branches, right? And you don't need to do this kind of stuff. You basically need to and will not really go into the next one. It's gonna also go back to the beginning of the loop, so it's gonna be interesting. So I haven't thought it through really well, but I already can anticipate that looping is gonna be very interesting. Okay. So what do we have in here? I need to go to the cross-referencing, right? So cross-reference blocks. Cross-reference blocks, where is the here it is. So yeah, essentially if I encounter else, I go back to if, and I set its address to IP +1 to the next after else. Alright, so that seems to be working, and in a simulation, where is this simulate program, right? So this is gonna be else, and the only thing we do, we just jump to that thing. All right, so I don't see any problems in here, and if I try to do that, so if I go to do this kind of thing, okay, so we've got 420, which is completely fucking incorrect, mate. Cool, I'm super happy. Yet again, we have some sort of bugs, but this is more of a like simulation bug, which is probably easier to debug, I think, but maybe not, who knows. So it's a true. In case of the end, I'll need to think. So this is going to be Porth by. Where is the cross-referencing? So if you encounter that, then else. We don't even have else right now, so something without else is already broken. I push my own address, so everything's fine. If I encounter and, I pop this thing out, check that it's if or else, and then I set its a return address to my current one, and that should be fine. That should be fine. I don't see any problems. Maybe it's dump. Is your compiler support nested ifs? Well, it's a really strange question because I'm in the middle of implementing ifs. Like half of an hour, maybe even, yeah, half of an hour ago, we didn't have ifs. You're asking that literally of me in the middle implementing ifs. So 30 minutes ago, we didn't even have anything. Right now, we started to have something, but in the middle of implementing that stuff. Can you add ifs, please? Well, I'll try. I'll do my best to add the ifs. Okay. So I don't see any mistakes in here. So everything seems fine. Right. So maybe the problem is within the simulation. Right. Simulate. Simulate. So if you have if, we do the pop, we check, and we either jump, if it's equal to 0, we jump here, or we do +1, and in case of the end, we always do +1. Again, I don't see any mistakes in here. That's really strange, but okay. That's very strange. Like this is a. All right. Oh. I need that -r flag. Who knows what just happened? Who knows what just happened? Like, what the fuck does it even mean? This is so dumb. Holy shit. I was trying to find a non-existing bug. Right, I'm running the simulation, and I'm also running the compiled program, and the first output is from the simulated program, and the second output is from the compiled one. And the reason why I also run the compiled one is because it's convenient for the compilation, right? Because I can compile and run it simultaneously. So I need some sort of a flag that basically, you know, -r, compile and also run it. But maybe for now I can just, you know, run this entire. I don't know. It's kind of difficult, but yeah, there is no bug in here. Basically, what I'm saying, there is no bug in here. It's just me being dumb. Okay, or maybe the program not being particularly, you know, ergonomic to use. Right? It's not particularly ergonomic to use. Anyway, so let's actually try to make this statement false, right? So we're gonna make it false, and it doesn't print anything. Okay, that's perfect. So the next thing I want you to do, if this entire thing is true, let's try to print 69. If it's false, let's try to print 420. Right? You see what I'm doing? So we're trying to test two branches simultaneously, right? So let's go ahead and do that. And something went wrong. Okay, that's cool. Push append. Okay, so 69 is printed in case of true, and it is in fact true. So it is equal to 69, and it printed 69. So if I make this entire statement false, it printed for 20. There we go. So we have if and else. So we can, you know, distinguish between them. And maybe here somewhere we can just print some gibberish at the end, right? So no matter what, whether a condition is true or false, that gibberish at the end should be always visible. Yeah, there we go. So it's always there. Okay, so we have if and else. So the question is, do we support nested ifs and else, right? Somebody asked in the chat, Zozin, do you support nested if and else? Let's actually check it out. So we can do something like one if. So this one is going to be, I don't know, 23. Else is going to be 42, right? So this entire condition is true, right? So this entire condition is true, and it printed 23. So you see, this is true, it went here, and then it went here. If I put false in here, it should print 42. There we go. It should print 42. So here are two nested ifs in here. If we make this condition false, it's going to always print 420, no matter what you have in here, because this entire block is going to be skipped. Right, you see, it doesn't matter what I put in here, it always skipped. So there we go, we support at least two nested ifs. Do you need a confirmation whether we support 3 nested ifs? Or maybe induction is enough? So, yeah. I think it's working. Alrighty, nested ifs without array of ifs. Yeah, so that's the beauty of the reverse Polish notation. Like, I don't understand why people don't use reverse Polish notation more often. It gets some time to get used to, but it simplifies the writing the compiler, because I don't even need to form the AST. I can just translate this entire thing and just don't worry about anything. So, all right, so what do we have in here? Okay, so this is only simulation, right? But we also need to have a compilation, right? And compilation, as far as I know, doesn't work right now. Right, we don't have a support for else in here. Don't have a support for else. This one is gonna be very, very interesting. Okay. L if OP, 0 if OP else, out or right, 1, 2, 3, 4, else. And what's interesting about else is that it always jumps unconditionally, right? It always jumps unconditionally. So that means, yeah. First I need to assert that we even have an address to jump to. So else instruction does not have a reference to the end of its block. Please call cross-reference on the program I'm trying to compile. Okay, that's cool. So now I'm gonna do out right and 1, 2, 3, 4. I'm gonna unconditionally jump to the address that is specified in the second operand, like so. So, but here is the interesting thing. It also should set up the label for if to jump to, right? And if always jumps to the next address after the else, right? So that means we'll have to do out right address d, and this one is going to be essentially IP plus 1. Yeah, there we go. So that's what we need in here. It's going to be IP, well, I mean, without any comma or anything like that. So that should be fine. So I don't see any problems in here. Yeah, let's try to compile. And of course, I forgot to update my counter in here, my trusty counter. And okay, right takes exactly 1 argument. Okay, I see the problem. I see the problem yet again. Okay, so generated assembly that just compiled. I don't know if it works or not, but let's take a look at the assembly itself. So we have a bunch of stuff in here that cross-references around and whatnot. So that's pretty cool. and it compiles, right? So I haven't tested it, but it compiles. And as you know, if it compiles, it works. Oh, I'm sorry. So let's try to run this entire thing. I'm gonna do foo, and it returned 42, but is it supposed to return 42? I think, okay, so this is true, and this is false, and it returned 42. Okay, so if I try to run like 1 in here, and just run it, it's supposed to return 23, and it returned 23. If I make this false, it's supposed to return 420. Okay, so it works. So we not only can compile if-else, we also support compilation of nested if-else. Are you on Python 2? I'm actually using Python 3. If not, do you know about f-strings? Yes, I do know about f-strings. And if yes, do you have a reason to not use them? No, I don't have a reason to not use them. It's just a force of a habit. So, yeah. All right, so I think we have everything working, more or less, and I think I can officially say that we have a full support for if conditions. Like, seriously, we support if, else, in simulation, and compilation. So it's pretty cool. That is in fact pretty cool. All right, so let me see. So this is how basically our language is going to look like, right? It kind of looks like Ruby, if you know what I'm talking about. It's like a weird crossbreed of Ruby and Porth, I suppose. I don't even know, like I never really properly programmed in Porth. How conditions look in Porth? Like Porth conditions. Do they look like this, or do they look like some... So they use if then. Okay, this is kind of similar. Zizex knows subscribed at tier 1. Thank you so much for tier 1 subscription, and welcome to Epic Compiler Club. Code compiler compiles if Tsodin happy, yeah. I really like when things I do actually compile properly, actually work properly. This one is kind of strange, like where is the else? So if condition phrase. Oh, okay. Oh, it just skips the... Okay, I see. All right, makes sense. So let's do a committee, maybe even pusher. Implement else support for if construction. Else for if construction. There we go. I'm gonna push that right into the repo. Again, you can find the source code of the project in the description, or if you're watching on Twitch, you can find that in the chat if you're interested. Alrighty, so I suppose the next thing we need to implement is while loops. Right, the next thing we need to implement is a while loops. So I would argue that maybe, well, for while loops is going to be rather interesting, to be fair. Let's give it a try. Full Porth. Imagine that we can start with some sort of a counter, right? We're gonna start with some sort of a counter. And then I need to check a particular condition, whether this thing is equal to 0 or not. I suppose I'll need to duplicate this entire stuff, right? Duplicate it, put 0 in here and check if it's equal to 0 or not. And then I can do something similar to if, but instead of if, I'm going to be using while, right? And then I'm going to repeat this entire stuff. But the question is, how am I going to check the condition again? So if I assume that while pops out the current value from the stack and checks the condition, that means I will have to repeat this condition yet again at the end of the body, if you know what I'm talking about, which is not particularly convenient because kind of the point of while is to not repeat this entire stuff. So I think while should work slightly differently. I think it should work slightly differently. So what if we put while in here, right? And we can sandwich the condition between while and something like do, right? You put 10, and while this condition, you do that. And then at the end of this condition, what you can do, you can basically do 1 minus, right? And you basically subtract 1 from the current thing on top of the stack. And you keep repeating this entire thing. Okay, that actually might work. I think that actually might work. And what we're gonna do on each iteration, we can duplicate, I suppose, the current value and just print it. Okay, so I think that works. Holy shit, this is actually pretty cool. Yeah, so we put 10, while 10 maybe greater than 0, we'll have to introduce greater. While it's greater than 0, we duplicate that 10 and we print it. Then we subtract 1 from 10 and we jump back into while, which will check this condition yet again, and so on and so forth. I think that might work. I think that might work. So... What do you guys think about this construction? I think it's a pretty good construction. So this is how while loops will look like, I suppose. So when you go back to here, it will jump to while, then it will check this condition, and if it's false, do will essentially jump back to end. So, hello for the first time on channel, and noticed such a thing on your t-shirt from the Student Olympiad. I see, yeah, it is actually. It is 2011, 2012. I'm not sure if you can see that, but there we go. Okay, can you see that? 11, 12. It was a long time ago, actually. Almost 10 years ago. Holy shit, I'm so old. So basically while repeats until the top of the stack is false. Yes, that's basically what it does. And I like how it looks like a proper while from, you know, like an actual programming language. I wasn't even alive that time. Are you 13? All right. Do you participate now? No, I'm not participating now. Okay, go. Okay, let's go ahead and introduce the while loop. Well, wait a second. We'll probably have to introduce all of these separations, right? Because we do have minus, we do not have greater, and we do not have dupe. So we'll have to introduce all of that stuff. So, but it means in your while line you do an operation, dupe in this case, but it can be replaced by another one. I don't understand what's the problem. Yeah, it does grow the stack a little bit. Okay, so let me see. So let's go ahead and just introduce. We're gonna start with introducing dupe, I suppose. So this is gonna be OP dupe. And I'm going to recompile the entire stuff. Okay, so right now I'm trying to compile. I want to simulate this thing instead. So this is going to be 9, and this one is going to be, well, if word equal dupe, and I'm going to return dupe. So this one is actually super easy because it doesn't require any cross-referencing, so it's just yet another operation. Dupe, return, OP, dupe, there we go. And invalid while. Oh shit, here we go again. I don't have comments. Shit. We need comments, chat. We do need comments. So I'll leave, you know, some sort of a to-do. That's what I want to say. to do Lexa does not support any style of comments. Okay, completely forgot about the comments. What kind of programming language do programming without the comments? All right, so what else do we have in here? So I need to separate this stuff. So this is going to be while, right? And I'll have to create full Porth, right? And I'm going to just put 69, and I'm going to do dupe, and I'm going to do it like several times. All right, so let me try to compile this entire thing. So now it fails in cross-referencing. So in cross-referencing, as it says here, not all of the operations needs to be handled here, only those that form blocks. So because of that, I'm going to just increment 9. Right, so now we go into the simulation, and let's handle that. OP dupe. So I take this thing, I pop it out, and I actually push it back onto the stack twice. That's it, that's the entire thing actually. There we go. And of course I forgot to increment this entire thing, and there we go. So it works, you see. If I don't dupe any of these things, it will do a stack underflow, right? So, but if I dupe them, everything works as expected. So now we have a dupe operation, but we don't have a support for compilation, right? So let's do compile. Yep, there we go. So let's see. I think it's going to be the same, right? So essentially we're going to pop it and push it twice. There's nothing much we can do anyway. OP0 equal OP dupe, right? So it's out right. Form dupe. There we go. Out right. 1, 2, 3, 4. Pop rex. And then we just push rex twice. That should be it. And let's update the entire thing. And if I try to run the entire program, it also works. There we go. That was easy. That's a pretty easy operation to introduce to our language. There we go. Introduce dupe operation. Cool. I'm gonna push that right into the repo. What else? I think we also need something like grader. Make optimization just append once instead of pop and 2 pushes. Interestingly enough, we're gonna do optimizer as a separate stream, right? So right now I don't really care about generating the most optimal code. I just like generate it explicitly, verbatim, right? And then once we have something working, we can start working later on optimization and stuff like that. Because optimization is going to be rather interesting. I think you can apply very interesting optimizations. For instance, if you have something like 1, 2, 3 plus plus, or maybe just like 1, 2, 3 plus, there's no point in generating code push 1, push 2, and then pop rex, pop rbx, and then add rex, rbx, and push rex, right? So because this is what our compiler will generate right now. There's kind of no point in doing that. We can detect these patterns on the level of compiler and just generate something like move rex1 and then add rex2 and push rex, right? We can try to do things like this, right? If we know all of these values at compile time, we can generate more like efficient assembly instead, if you know what I'm talking about. So that's gonna be my plan. Yeah. All right, so we need a thing grader, right? So we need a thing grader. Did I compile everything? Okay, so I mean commit everything. OP GT iota. Let's recompile this entire thing. So what do we have in here? If word grader, and I'm going to just return GT. Deep GT return OP GT. There we go. course, I forgot to update this thing in here. So yet again, this is an operation that doesn't form any blocks, so it doesn't matter. And now we're going to be doing a simulation of our nation. So this is going to be 10 right away, and if we encounter something like OP GT, out, right, 1, 2, 3, 4, GT, greater. Okay, I think we can do something similar to equal. Right? So we have that, we do CMP, and okay, I can straight up steal this entire code. I'm pretty sure I can straight up steal it. So this is the false and this is the true. And do I have CMove GT greater, or maybe CMove G? I wonder. Okay. So let's go back to Porth. I forgot to write the code that, you know, actually checks everything, right? 420 less, and if this entire thing is less, I'm gonna print something like 1. Otherwise, I'm going to print false. This is gonna be the end. So now I can quickly check this entire stuff, and all right, invalid literal for int with the base n, and I actually never. Shit, okay. This is what I wanted, I'm sorry. I'm already getting tired. Okay, so for 20, alright, so this is incorrect order. So we have to pop them out in a different order, right? So because now I pop this, and okay, that makes sense. So where is my stuff? So what I have to do is just like pop RBX and pop rex. I think this is what's needed in here. There we go. Here's one. And now if I swap their order, right, this is gonna be false. Okay, so it's working for the compilation. So we have greater, and it is in fact greater, right? So we have this thing. But for some reason, first I implemented compilation, now I need to implement the simulation. I think for the simulation we haven't implemented it yet. So, okay, L if OP0 equal OP GT, A stack pop, actually it has to be like B, and then it's gonna be A, and stack append A less than B, and we have to convert it to integer, of course, and then we're gonna increment like so. Okay, so yeah, it's flipped yet again. Right. Oh, okay, so I'm actually was doing it correctly first time. Okay, I'm getting tired. So this is the false and this is the true. Okay, cool. So we implemented greater. To some extent. So, and let's do a committee. Introduce greater operation. And I'm gonna push that right into the repo. Okay, I think we have all of the necessary operations to pull this off. We have dupe and we have greater, so we only need to implement while. So let's go ahead and introduce two main blocks in here, two main tokens in here, while and do. So it's going to be Porth, porth.py, and while, iota, and do. There we go. And let's start with the simulation. So I'm going to try to simulate while. So here is the parsing. So we introduced two of them, elif, word, while, and we can't just use while. So I'm gonna call it while. Else if word equal. So maybe at some point I'll have to introduce some sort of a map in here. Yeah, I think it's gonna be useful to just introduce a map. And then if it's not in the map, try to parse it as a number or something. Yeah, at some point I'm gonna collapse it, but not right now. So this is do. So we have while and do. And this is the only place where we construct this thing, so I'm not sure if we really need those like constructing functions, but I keep introducing them just in case. But yeah, so I'm not trying to like, you know, form the architecture ahead, right? I'm just trying to copy paste code until the pattern emerges, and once the pattern emerges I can collapse this pattern and compress it. So op while do return op do. There we go. Okay, cool. Forgot colon. Okay, so now let's take a look at this stuff. Cross-referencing. Okay, so here is the block that is actually important for cross-referencing. If we encounter the while, right? If we encounter the while, so the only thing we can do in here is essentially just push the address of this thing onto the stack, right? There's nothing much we can do anyway. Otherwise, if we encounter do, this one is very interesting. Oh. Alright, so let's go back to the drawing board. Because it's going to be interesting, I think. Because it's not the same as with if-else construction. It's not the same as with if-else. Just a second. So this is the while. So while itself doesn't really need to jump anywhere, right? Condition. So it doesn't really need to jump anywhere. So then we have something like this, and then we have end. So when you encounter while, it should just fall through. Then we compute the condition, and do will jump either, like it will either fall through or jump to the end, right? It will jump to the end. And the end itself will jump to while, right? So because of that, I think do shouldn't jump to the end. I think do should jump to the instruction after the end, if the entire condition has fallen, right? Something like this, some way here. So this is the like main workflow. You go in here, you fall through the while condition, do consumes the condition and either falls through or jumps you know, ahead of itself. And end jumps always back into the while. So while basically becomes a marker where to, you know, check the condition yet again. So because of that, do doesn't really care about the position of the while. Do doesn't really care, but end does. End does care. So when we encounter while, we're going to push its address to the stack. Then we do the condition, we encounter do, we take its address from the stack, and this one is going to be really interesting. So the end, I think the end will need to know both addresses of do and addresses of while. I think I need to make a small break, by the way, because yeah, I've been programming like for 1.5 hours, and it's really difficult to focus. So I'm gonna make a small break, boys and girls. I think I have an idea on how to implement that. So essentially, when we encounter while, right, we put this IP address. Okay, so then when we encounter something like end, op end, we're gonna take the while IP 4MSal4 is gifting 5. You already gifted 5 subs, I think. Yeah, you gifted total 10 subs. Thank you so much for gifting the sub, and everyone who got the sub. Welcome to our epic compiler club. How are you guys doing? So thank you so much. You're being too generous to me, seriously. So yeah, I really appreciate that. Thank you so much. My pleasure. Thank you. All right. So let's pop it out. Does anyone have any questions maybe about what we're doing right now while the entire thing is playing? So I'm going to take a look at some of the questions in the chat maybe. So I don't understand your schedule. Which day is it today? Random day. Oh yeah, the schedule right now is completely irrelevant. I don't follow it anymore. I'm sorry. It's kind of difficult for me to follow a specific schedule these days. So yeah. Your advice for people who is just at the beginning of programming. Only at the beginning of programming. So I think these days it's kind of more difficult to learn programming than it was when I started. And when I started, it was more difficult than, you know, in the past. I think learning programming gradually becomes, like from scratch, gradually becomes more and more complicated because there's so many different technologies and so many like paradigms and stuff like that. And it's kind of difficult to find the, you know, the essence of programming, like learn the essence of programming these days. And my advice, what would be my advice actually? I suppose take everything with a grain of salt. If somebody tells you that this is the only like right way to do things, never trust them, right? So because it's never true. In programming, there's always multiple valid ways of doing the same thing. And if somebody is trying to tell you the technology that will revolutionize everything and that's the only way everyone has to develop, never trust them, because it's never the case. Depending on the situations, you may want to do different things. So I guess that's the advice I can give you. And it becomes more and more difficult to learn programming like gradually, because people come up with more and more marketing bullshit to sort of like, you know, how to say that. I don't know, I don't have a vocabulary to actually explain what I'm trying to say, but what I'm trying to say is basically take everything people say about programming with a grain of salt. Even me. Don't even trust me. Always check everything yourself. Right? If somebody's saying that a particular way of programming is the right way to do that, try that way of programming and make a conclusion for yourself. Right? Just try that and see if it works for your particular case. Right? Because it might not work for your particular case. Never trust those YouTube whip. Yeah, exactly. Never fucking trust them. Like, holy shit. So what your program gonna do? It's gonna compile other programs. It's gonna create other programs. Programming has become a pop culture. Yeah, it's insane. All right. So thank you so much for all the subscriptions. Right. So when we are at the do, right, so we're doing the do, I take the while IP, right, and I think I have to remove it from the stack. I already removed it from the stack, but essentially what I have to do, I have to do IP, program IP0, maybe I can even do op do, and I'm gonna just save the while IP in myself. So I'm gonna save it in myself, and then I'm gonna push my current IP onto the stack, right? So that's essentially what I'm gonna do. Alright, so that seems to be great. Essentially, we put the address of while into the stack, then we encounter I do, and we save that address in the do itself, so then we can reuse it at the end. So that's basically going to be the idea. All right, so, and when we encounter end, we need to check that this OP is do. And if it's do, we're gonna try to do something. Not implemented. And can only close if, else, or do blocks for now. Right? So that's what we're gonna say in here. And if we encounter do, right, if we encounter do, what we need to do is also assert that this specific operation has enough arguments, because we store the location of while in do, right? So after that, so this is a block IP. And what I need to do, I need to save. So this is going to be program IP OP end. Oh shit, we never actually did that before, but maybe it's not important. Maybe that's not important. G is here. Hi. Jay, hi, I didn't notice you, I'm sorry. Hello, hello. So yeah, we're doing the while loop compilation. We already have ifs, so our application is capable of actually compiling this, and it works. So we're in the middle of compiling while loops and stuff like that. So, yes. Kawaii freaking this. So now we have OP end, right? So we have OP end. Oh boy, an end should jump. Yeah, end should always jump to the beginning. So program block IP, and it's gonna be 1. So that means I redirected end to the while. But now I also need to do something like this: block IP 1. A block IP just like this is gonna be OP do, which jumps to IP +1 in case it needs to skip something. Yes, in case it needs to skip something. And because we're always setting up the end, we have to do that for this thing as well. But in that case, it is going to be essentially IP +1. So, okay, this is actually pretty cool. Alright, so essentially we're just setting up like different cross-references between these things so we can later use them for interpretation or for the compilation of our nation, of course. So, and I hope I didn't make any mistakes in here, so should be fine. Okay, so let's go ahead and just recompile the entire thing. So return the program indented block, so I did a fucky wacky somewhere here. So I think I just have to ignore this stuff, right? Because yeah, I just could have pasted it accidentally. So this one is 11. Fucky wacky. Oopsie doopsie. So in that, I think it has to be 12, right? We added 2 operations in here. Alright, so and stack append yet again. I keep confusing append, so it's kind of weird that in Python lists have append and pop. So what do you expect to have it push? If you have pop, you usually have push, but it's called append. So thank you Python, very cool. Okay, so we have exhaustive handling. So we added a very interesting thing to the end. Stuffsin, minus $5.
Цудинфилос $5 США.
Thank you so much for 3 months of tier 1 subscription. Minus $5 of США indeed. Thank you so much. I really appreciate it. But keep in mind, it's not wasted. I'm gonna buy a tea with these dollars. Thank you so much. One will be able to donate negative amounts. So that means I'm gonna be bankrupt if if people will start donating negative amounts. Alright. So end instruction does not have a reference to doesn't have a reference to where? To the next instruction to jump to. Please call cross-reference blocks on a program for trying to simulate it. Okay, so that makes sense. And that means in here it's just like OP1. Alright. It's just basically OP1, which makes else and AND the same thing, right? So it's the same thing now. And now we need to introduce like whiles and whatnot. This one is going to be rather interesting. L if OP0 OP while. I suppose while is not going to do anything. It always like just jumps to the next instruction. Do is rather interesting because it's going to check the condition. Stack pop, right? So we have stack pop. And if A is equal to 0, that means it's false and we have to skip everything. And of course we will need to check this thing. I probably need to extract this assert to something else because it's kind of cringe, not gonna lie. So I'm thinking how we're gonna do that. Nah, I'm too lazy right now. Maybe gonna do that later. So IP is going to be equal to OP1, so this is where we're jumping. Otherwise, we're going to jump to the next operation. All right. So this is what we do in here, and with the end always jumps back to the while. Okay, so that's fine. That should be it actually. That should be it. So let's actually recompile the entire thing, and I forgot to update this entire stuff. Okay, so what I'm trying to run is a while Porth. Okay, so this is 10. It will check if the value is greater than 10. All right. And while it's greater than 10 is going to duplicate this value, print it, and subtract 1 from it, and then go back and check again. So this is basically going to print values from 10 to 1. So yeah, that should be it. So let's see if it's going to work or not. So we are in a simulation mode. The fuck? First try? What the fuck? I didn't expect it. Okay, so it's rather interesting. So at the end we can actually print something like 6969, right? Just to denote the end. What if I try to print like 100? It works 100. So we have loops. We have loops and ifs. Well, at least in the simulation. Okay? So we can't compile those loops yet. We can't compile them, but we're almost there. Okay, so let's try to compile the entire thing, and it will fail, of course, because we don't handle the separations in here. All right, and is rather interesting because now and stores basically the address you have to jump to, which is probably may break some of the things, right? So it is rather interesting. So we're jumping to the end, and end was always jumping to the next one. But maybe not. Oh boy. So this is actually super easy to make a mistake, but so you know what? Maybe we're gonna do the BM or bosom thingy where we annotate each individual instruction and just don't worry about that. So just like each individual instruction is always annotated. That would be kind of cool. So, and that means we won't have to worry about that at all. So let's give it a try. So where's my foo? So here's that thing, and I'm gonna just, you know, suppress this entire stuff. I'm gonna always do out right address D, new line, IP. So that what we have in here. So address, so we don't have to do that, we don't have to do that, so this is going to be pass. So where is the other address? So I think that was it actually, I didn't see any other addresses in here, so this is going to be like that. So we only jump into them. Okay, cool. So we only always annotate this entire stuff. And now if I try to compile foo, it seems to be kind of compiling, but not really. So what was the problem in here? I don't understand, right? Yeah, so this is the classical thing. Okay, so everything compiles, and if I take a look at the foo-asm, there we go. So for each individual operation here, we have a label, and it makes it easier to jump between them. Okay, so that's fine. That is totally fine. So we don't have to worry about that. Now, when I do the end, I want to check that the end has the cross-reference, right? So, and the instruction doesn't have a reference to the next instruction to jump to. Please call the cross-reference verb before trying to compile it. Right, so, and now I should be able to do the following thing. Out, right, 1, 2, 3, 4, jump, address, D, and yet again it becomes basically like else. There is no difference between else and end. It's kind of the same like operation. It's kind of the same operation. Okay, so now I need to handle the rest of the stuff. I need to handle the while, OP while, assert false, not implemented, and do. In case of a do, I think we literally shouldn't do anything. Right, so we basically fall through. Yeah, we basically fall through. Yeah, so it's something like this. Do is more like a if, right? Do is more like a if, but for the while I think we could at least print that this is the while. 1, 2, 3, 4. While, like so. So this is the while, and do, we also need this thing for do. So maybe I can steal some stuff from the if. Right, let's see. That's for sure. Do instruction doesn't have a reference, blah blah blah. And if it's false, we have to jump. Yeah, we have to jump to the end. If we did everything correctly, we would have to jump to the end. Okay, so that is it actually. That is it, I think. I'm pretty sure. So we're gonna have a while loop soon. Address 10 is not defined. What the fuck? Why don't you have? Because it's at the end. Oh shit. All right. So we always have to have like a address at the end. Let me take a look. So this is the while. But we're trying to compile 4. Yeah, so it tries to jump to the end, and it doesn't see the end, right? And we always have to have that. Oh boy, oh boy, oh boy. We can do something interesting. For instance, if we know our own address, right? If we know our own address at the end, and if it's equal to, yeah, if IP plus 1 is not equal to OP1, that means we do the jump. Yeah. Okay, that's actually pretty cool. It's actually pretty cool. So we can do something like this, and now it will compile. And if you take a look at the assembly, yeah, it's just didn't generate anything. Yep. It didn't even generate end, I think, which is rather strange. Oh, because we never actually generate end. Okay. So we take a look at this stuff. Yeah, here's the end, and it just like doesn't do anything. Okay, that's cool. That's pretty cool. Alright, so I'm already done, actually, believe it or not. It's just like I'm hesitating a little bit because I'm not sure if it's gonna work first try or not. Let's try to compile the while loop, and while loop seems to be compiling. Let's take a look at the assembly. Right, so here's the assembly, and yeah, so we jump to address 1. And this is where while starts. We also check some stuff, and we keep repeating everything. So I guess that is it, believe it or not. So we should just go ahead and just try to run this entire program and see if it actually works or not. It printed 1, so it doesn't work. Nice, thank you very much. I wonder why. Maybe because minus is not correctly working or something. So if I take a look at the while Porth, yeah, it's supposed to be printing. It printed only 1, which is rather strange. What the fuck? So if I, okay, so I'm running the wrong program. I was supposed to be running while, and it works. There we go. So this is the compiled version. This is a compiled version that works, and we generated that thing from this program. So we have while loops and if conditions. Holy fucking shit! Oh my god! So and I can control that. So I can have like 5 of them, right? I can now recompile the entire thing and just run it, and there you go. Everything seems to be working. Yep. We can compare the performance of the native code. So this is the performance of the native implementation, and then we can compare the performance of the simulated one. So 1 millisecond native Python 87. So Python 87 times slower than the native version if you use Python as a simulator. So that's pretty powerful. Not gonna lie, this is actually very, very freaking cool. But the compilation, of course, like it's a little bit slower. All right, we have a while loops. Holy fuck! What the fuck? So yep. I guess the only thing we need for Turing completeness is arbitrary access to the memory. And after that, we probably will be able to implement something Turing complete, like you know, Rule 110 or Game of Life or whatever. So yeah, I didn't expect that it's gonna be so easy. Actually, it's actually quite surprising how fucking easy it is. Didn't really need much. Okay, let's do committee. Introduce while loops, and I'm going to push that right into the repo. If you are interested in the source code of this entire thing, you can find it in here, right? And if you're watching it on YouTube, you can find it in the description. I'm going to put it in the description as well. So yep. Does anyone have any questions about what we're doing right now? What are you doing? Are you making your programming language? Yes, I'm making my own programming language. Why don't you do a fizz buzz in Porth? Because I don't have enough operations for that. Just looking for the questions in the chat. How are we going to arbitrarily access the memory? This is a good question. So I think we're gonna have some sort of like a read and write operations, right? Essentially, which yeah. So maybe I'm gonna have a pointer, right? I'm gonna provide the address of something. address of something, and then I'm gonna say read the value at that specific address, and it's gonna push that value onto the stack. So then I'm gonna push 10 and sum it up, or maybe compare it, right? So if I have some sort of a variable x, I will be able to read it, compare it with 10, and maybe put it into some sort of a loop. So this is how I'm gonna do that. And what's interesting is that x, since x is address, I can work with it as with address or as a value. So read in this case is going to be sort of like dereferencing, or maybe I'm going to even have something like deref, deref operation. Yeah, so this is how it's going to go. This is reading, right? And writing is going to be something like, so here's the pointer, here's the value, write, right? Or something, maybe store. Right, it's more going to be like store. So, yep. We also need a way to call syscalls, because we'll need to do a dynamic memory allocation. I think it's going to be interesting, because as we start the application, we don't really have any runtime. We don't link with any C library or anything, so we don't have a malloc. We'll have to implement our own malloc, and to implement our own malloc, we'll have to interact with the operating system. We'll have to ask operating system to extend the size of the program via the brk syscall, right? So something like this. I think we're going to start with the brk syscall and extend the data segment. Or maybe we're going to call to mmap to allocate more memory, right? So to map some memory pages, and then we'll be able to use those memory pages to put something in there. So that's how we're going to work with all of that. So at least that's the plan. Yes. Is it possible that stack has wrong value when it pops the stack to get IP to jump to? I think you misunderstood what we're doing. We're not pushing IP onto the stack anywhere at all. So yeah, at least right now. We're not pushing anywhere. So the IP that we store to jump to is only known at compile time. It's a compile time value. And once we resolved everything, at the runtime, it's really not known. It's like becomes baked into the entire thing. So it's more of a compile time value rather than runtime one. So does anyone have any other questions? Maybe about this entire thing? You can find the source code of this thing in the description or in the chat. So yeah, we're making like a very simple programming language in Python, but the cool thing about this programming language is that it's compiled, and we're generating a native assembly, and yeah, that's pretty cool. So the choice of Python is completely arbitrary, actually. So I could have implemented that in any language. I just decided to use Python because why not? It just doesn't matter. Could have implemented that in C, maybe in Java, JavaScript, it doesn't matter. Like I need any language that can generate text. So I just randomly picked Python. So we're getting closer to Turing completeness. So after we're done with the Turing completeness, we're gonna make it statically typed. So we're gonna actually check the types and stuff like that. So the type checking is gonna be similar to WASM validation step. So if you're interested, you can watch it in here. Your compiler course is also in Python. Why? Are you guys writing also writing compiler in Python? Why would you do that? Well, I mean, obviously I do that because I don't know. Oh, okay, that's very interesting. That's really strange. Very well then. Maybe for the same reason, so it's a completely arbitrary decision. Are you compiling it into some sort of a bytecode? Oh, it used to be Java, but people complained about it. Okay. Are you compiling it to some sort of a bytecode or assembly or something else? Into ARM assembly. Okay, that's nice. Pretty cool. Alright, and another milestone for our language is going to be self-hosting. So once we implement enough functionality, we're going to re-implement the language in itself. And I really want to try to do that because I never implemented a self-hosting compiler in my entire life. So I want to use that as an opportunity to do so, right? It's just like interesting to see how you do this kind of stuff. So yep, that's pretty cool. It's completely open source under MIT license. You can do whatever you want with it. Don't forget to star, of course. Don't forget to star. And if nobody has any other questions, I guess I gotta go, right? So I implemented everything I wanted to implement today. I implemented if conditions, while loops, and on the next stream, we're gonna implement the memory access. So it's gonna be interesting. All right, that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you on the next session. All of that stuff is going to be available on YouTube, so you can check out the YouTube channel where we upload all of the VODs. And I gotta go. Thanks everyone for watching. Love you.